This type of question has appeared on many practice questions that the College Board has released, so I think it's a fair chance to say that you're going to see this on your test, probably at some point, one of your tests. So the big thing here is to avoid the most common mistake. And remember, a question like this comes from one of the linear tests, the paper version of the SAT that is offered to those with accommodations. That's why this is a number 27. But on the digital, this would be like a number 20 or number 21 or something, right? It'd be towards the end of the module, you would know it would be hard. So if you did the following, you might want to be a bit skeptical, right? So here we've got this area of 46.00 square nautical miles. I'm not sure what the symbol for that is. I'll just say miles squared for now. Is equivalent to k square kilometers to the nearest tenth. What is the value of k? So you might think, oh, look, if 1 nautical mile is 1.852 kilometers, let's just go ahead and multiply this by 1.582. So 46 times 1.852. I get 85.19. We got to round that to the nearest tenth, so that becomes 85.2. And unfortunately, if you put that as your answer, it would be wrong. It does not work because we are making a mistake with our units. And again, if this is a number 21 in Module 1 or Module 2 of math, is it really going to be that simple? You just multiply 46 by 1.852? If it's a number 7, probably yeah. But for number 22 or 21, just double check your work because most likely it's a bit trickier. It's not that much harder, but there is a little wrinkle. So the reason why this isn't working, if I put this back in, let's put our units in, which we kind of left out here. So what I'm doing really is I'm converting from miles to kilometers using this conversion of 1 nautical mile is 1.85 kilometers. But if I look at the units here, one of my miles units will cancel. And so when I got that 85.2, whatever the answer was, the unit was miles kilometers, which is a nonsensical unit. We wanted square kilometers, kilometers squared. And so the units reveal the problem. That's why when you're doing any problem involving any kind of unit conversion or even other problems where units are involved, pay attention to the units. They keep you on the straight and narrow, right? They allow you to figure out what to do, make sure you're not making mistakes, verify your answer. Once you have the units in place, the numbers are straightforward, relatively speaking. So let's delete all this. Let's write 46.00 miles squared. And then we're going to do our conversion, right? We want to convert to the nearest tenth. What is the value of k? So we want to convert from miles squared to kilometers squared. So what I need to do from a unit perspective is I need miles squared on bottom and I need kilometers squared on top so that the miles squared units cancel and I'm left with my kilometers squared, which is the goal. Now that I have my units in place, what numbers do I put in? Now I don't have a direct conversion from meters squared or miles squared to kilometers squared, but I can get it. Because if I have this ratio, I can essentially, it's like squaring both sides of an equation. I can square this relation to find that it's going to be 1 squared miles squared, or 1 mile squared, is going to be the same thing as 1.852 squared kilometers squared. So we were very close when we multiplied 46 by 1.852. We just had to do that again, basically. So let's multiply by another 1.852 because we're multiplying by 1.582 squared. I get 157.7, and we're going to round that to the nearest tenth. So we get 157.8, and that is our answer. So as always, with your units, take them seriously. If you've spent any time in a math class or a science class where your teacher is making sure your units are in place and you're losing points on tests because you forget units, maybe annoying at the time, but there's good reason for it, and we see why here, right? If we don't pay attention to the units, if we just look at these numbers as dimensionless quantities, we try to combine them, there's really no rigor, there's no foundation for what we're doing. We're just throwing numbers around. What matters here is a conversion from one unit to another. And so if we're rigorous with the units, it solves a lot of our problems and helps us avoid mistakes. It can also help us figure out what we need to do. If we're lost, sometimes what I do, if I'm lost on a question, is I say, okay, what are the units of my quantities here? Does that tell me something about how I'm going to get from where I am to where my answer is going to be? Can I make some unit conversions, or can I think about the units in a way to help me understand the problem? So take units really seriously, and they'll help quite a bit. So the answer to this one again was 157.8.